A sampling procedure that yields a simple random sample is what is ideal. And the idea with a simple random sample is that, let's say we want to construct a sample of size n equals 30 from some population. Then what needs to be true in order for us to have a truly simple random sample or random sample is that given any subset of the population of size 30, that particular subset has to have had the same chance of being selected as any other subset of size 30. So there can't be any bias. Okay, so that's the idea. So as it says here, that each possible sample of a given size is equally likely to be obtained. So no particular sample is any more likely to be chosen than any other. So that means that the particular sample that you get had the same chance of being selected as all the others. Okay, so at the bottom, let's focus on sampling with replacement versus sampling without replacement. And I think that kind of speaks for itself, because if you conduct sampling with replacement, that means you could potentially select the same unit in the population twice, because once you select that unit to be included in the sample, then that unit goes back into the bag, if you will, back into the list of those which are considered to be chosen. In contrast, sampling without replacement is just what you think. Once you select a unit from the population to be a part of the sample, then that particular unit is not available to be chosen a second time. Okay, so obtaining a simple random sample, there are several methods, and of course, usually this is done using technology, but there are different methods, and it would be instructive for us to look at the different methods. And so the book gives this example of a table of random numbers. First of all, across the top, you can see that it gives you the column numbers starting with column 0. So that first column of digits, they would call that column 0. And then you have sort of grouped together column 0 through column 9, and then column 10 is here, and so on and so on. And then you see organized by rows, you have the line numbers, and again they start at 0. And so the idea is that you sort of randomly, close your eyes and point somewhere, so you can see that they've given us the example where somebody pointed to this 069. So we've got to get a random starting point. And then from there, well, first of all, let me back up. Our objective per the book is to randomly select 15 numbers between 1 and 728. And so since we're only looking at those numbers, anything less than 1 we're going to ignore, and anything bigger than 728 we're going to ignore. And so starting with the 069, you can see that we go down, and the next number will be that 988, and since that is out of range, we will not use that, so we'll ignore that. And then the next one is the 386, so 386 we will use. And then you continue in this manner, and you can see that they go down, and then when you get to sort of the bottom, then you just go back up, grouping together, another path where you have 3-digit numbers to consider. And then once 15 numbers have been selected, then we're done. And as this slide indicates, nowadays statisticians use software, so technology is used, like random number generators and things like that are much more likely to be used than that table. But I'm sure there are some situations where people would use, you know, a more manual type approach.